Good morning, everyone. I am Tuhin, and I am here to present the topic of my thesis, that is forecasting Indian stocks with a focus on the life cycles of major global events. So let's get started. Let's first understand what stock market is. Stock market is basically a marketplace where buyers and sellers meet to do trade. Now the sellers are represented by organizations, big corporates, etc. The buyers can range from individuals, businessmen, world leaders, and all those people. So the idea behind the workings of stock market is that if the seller has made profit, the buyer will get the piece of that profit, and if the buyer has incurred, sorry, the seller has incurred losses, the buyer will also incur losses. So it is very important for the buyer's perspective or the buyer's side to understand the fluctuating nature of stock market. And in order to do that, they do two kinds of analysis. The one is the fundamental analysis, which relates to observing companies' revenue and profit margins. The second analysis is more technical one, which evaluates the statistical results of stock price movements. Now, the third component of deep learning and machine learning technology has also been used these days, because these technologies can learn from the hidden patterns of historical data, and they can understand and predict what will happen in the future with higher accuracy than what a human can do. Now, let's understand what are the factors which can impact the stock price movements. Now, the factors such as environmental issues like floods or geopolitical issues like warfare, they can be impacted from a small tweet from a politician to a major issue like a terrorist attack. Now, understanding the nature of a stock it can tell a lot about a nation's economic health. It was seen in COVID-19 pandemic that a rise in automobile stocks were directly proportional to the closing of its manufacturing units. Or in during the Russia-Ukraine war, the impact of sanctions impacted the oil stocks. Some researchers have used variables such as Twitter data, economic indicators, in order to improve the performance of the models which are responsible for performing stock price forecasting. Now, every year, researchers, data scientists are developing new algorithms in order to further, improve the accuracy of the models. Let's understand the current state of research which exists in the stock price industry. The first part is stock market. The research, most of the research talks about forecasting stock price using machine learning algorithms. These algorithms are evaluated using metrics such as MAPE, RMS, etc. The third component is very rare, but some researchers have used it, is using global events to understand the stock patterns or detect crisis points. Now, what are the existing research gaps? Well, the lack of examining multiple stocks from a wide range of sectors using the same conventional metrics like MAPE, RMSE for evaluation, and lack of in-depth analysis of phases that exist in the timelines of global event life cycles. Now, the improved state talks about the holistic approach of incorporating the missing dots in the research gaps and incorporating the three conditions of current state, and also leveraging the use of volatility as a new form of metric for evaluating the performance of learning algorithms. So the basic idea is to incorporate all these things together and understand the stock price movement and pattern in a different way. Now let's understand the literature review. So these literature talks about how the machine learning algorithms were used to classify the direction of stocks. How how an author tried to develop an early warning detection tool to classify crisis episodes. How and how another author has used an exogenous variable like a geopolitical risk index to and incorporate it with stock and oil and all these kind of rates to understand if there is a empirical link between these assets. And some people have also incorporated exogenous data like Twitter data to understand the sentiments of events like global and local events. This part of the literature review talks about the efficiency of algorithms which have been used. So Arima showed a MAPE deviation of 5%. That means Arima was able to predict, the accuracy of Arima is like 90%, like 95%, because the error rate is 5% only. In some cases, people have used, CNN and LSTM model, which are both neural network models, to evaluate stock price of NYSE 50. Some study shows that Arima is good for forecasting for short windows. So, in all the literature, it can be seen that people have tried to incorporate the deep learning models like econometric models like Arima, all these things into in order to understand the stock price forecasting patterns. And some researchers have done it to understand to classify events as well. But these these research these research papers are not comprehensive enough to give us to understand the full capability of stocks or to understand the full capability of algorithms as well. Now let's understand the framework that has been used in this thesis. So we have tried to analyze 27 stocks from 10 different Indian industries, did some basic data preparation process by removing the missing values and all that, and we explored the three phases. We explored three global events, and we divided the global events into multiple phases, and we tried to evaluate the gist out of what is the impact of stock price movement on those phases. After that, we have incorporated three algorithms: the convolutional neural network, the Arima model, and the SVR model, the support vector regression. These algorithms are basically work by using initial training period. So, in order to have standardization across all the stocks and across all the global events, we have used one initial training period of 3 months for all of them, and it works by the method of rolling window. So 7 days are used for testing. So 3 months are training period, and then there is 7 days. So it will predict for 7 days, and then 3 months will move 7 days more, and it will predict the next 7 days. So this is a rolling window approach which we have used to understand the 7 day increment. Every time you run the model, it increases by 7 days. So this is a basic approach we have used in all of the processes in order to create a standardized process, so that there is no bias in selecting. We did not choose hyperparameter tuning in order to make sure understand how the basic model works. Now, after learning algorithms, we generated the forecasted values, and we perform two kinds of uh, comparative studies. One is MAPE score analysis, one is volatility analysis. The third is we also got inferences from the forecasting graphs. And these are all supported by the qualitative analysis of the literature that we have studied in the thesis. Now, comparative analysis will generate insights. The MAPE score, everything will generate insights, and these insights were calculated using deviations, like how, like for example, there's a actual value, right, and there is a forecasted value. How much difference there is between the actual and the forecasted is a deviation. So we tried to uh, understand the stock price movement or stock price pattern or the nature of stock price with by calculating deviations. Now, comparative studies. Now, same thing, the adjusted price was segregated based on the various timelines of global event phases. It was passed onto the forecasting model, and then it forecasted the closing price, adjusted closing price. Then it gave us the MAPE score. The deviations were used to understand. Then the deviations were created to create bins of MAPE score. Now, so these MAPE score gave us insights. Same thing happened with volatility. So the volatility that we have used in this thesis is basically standard deviation. So what we did is for each phase, and we divided the phases into periods. So for each period, we uh, use forecasting model and uh, created forecasted volatilities in order to understand the volatility deviations in the volatility analysis. Now this is the global event timeline and stocks. So we studied US financial crisis, COVID-19 pandemic, Russo-Ukrainian war. And these are the phases that we study, phases that we divided these global events into. There is housing bubble expands to aftermath of US financial crisis. In the COVID-19 pandemic, we try to understand the COVID incubation period all the way to the second phase of recovery. In the Russo-Ukrainian war, we understood how what was the prelude state of Ukrainian annexation, all the way to the full-blown invasion. So these are the timelines that we studied, and these are the stocks that we studied from multiple industries. There are petroleum and gas, there is hospitality, there is construction, there is agriculture, there is pharmaceuticals. So the reason for choosing these industries is because these industries contribute majorly to the Indian economy. So I think 90% of the Indian economy is run used by these industries. So it is done to represent the Indian economy, basically. Let's understand the best and the worst performing stocks. So as you can see, this is the actual volatility chart, and this is the global financial crisis in which the crisis periods were divided into 30-day periods. So P1 is 30 days, P2 is 30 days, like that. So this starts from the housing bubble crisis, goes all the way to the aftermath. So okay, so if we see the 16th column, we can see that this is Maruti, right? So as we can see that Maruti has high volatility. It is in somewhere it is showing red, which is 127. It is showing high volatility. This can be supported using the phases that we studied. The phase 1 is about the housing bubble crisis, and phase 4 is about aftermath. As you can see, the Maruti prices were going up in the phase 1. Suddenly, from phase 2 to phase 3, it started going down, and in the phase 4, it again went up. So similarly, if you see the Bajaj automobiles, the pattern is similar in Bajaj as well. The second and the third stage, it goes down. In the fourth stage, it goes up. So the volatility chart tells us about how volatile each stock or how volatile each industry is. You can easily see the 16th, 17th, and 18th are automobile stocks. You can see how these three stocks are going hand in hand with together, right? 25th, 27th, 25th, 26th, 27th stocks are one industry represented by pharmaceuticals. So in actual volatility chart, you can see that there is a pattern behind it. There is the stocks from one industry acts in a similar fashion. Similarly, for the COVID-19 pandemic, as you can see that the automobile stocks were impacted heavily. The seventh stock is about Apollo hospitals. As you can see, during COVID-19 pandemic, the Apollo hospitals were impacted heavily because they did a lot of profit. So volatility always does not mean that it is the losses. It can be profit, extreme amount of profits as well. So volatility is how fluctuating the stock is. So it can fluctuate into higher numbers as well. So Apollo is basically improving. But pharmaceutical companies are also showing high volatility. But in general, it can be seen that the entire stock market is extremely volatile, irrespective of the industry. Now, in the Russo-Ukrainian war, as you can see that the automobile is again impacted. Now, the Russo-Ukrainian war started when there was pandemic as well. So the study can be impacted. The study might have been impacted because of the ongoing COVID-19 pandemic. In this, you can see that the Gas Authority of India, which is a petrochemical industry, the stocks suddenly started to jump. It was going down and then it went up and then it was fluctuating too much. Similarly, the oil and natural gas was fluctuating during the Russian-Ukrainian war. Now let's understand the MAPE score analysis. So how the MAPE score were analyzed is according to the industry standards, a MAPE score which is below 5% is generally considered good, and MAPE score which is above 5, like 5 to 10% is considered to be bad. So we analyze MAPE score with global events and analyze the algorithms behind it. So this is the COVID-19 pandemic. As you can see, the CNN has performed extremely well in that it is able to predict for 100% of the stocks were below 5% MAPE for CNN and for all of them like that. So Arima and SVR are like trying to fight with each other in terms of accuracy. Similarly, but CNN is consistently good across all the events. Now this is about the negatives of this MAPE score analysis. So anything which is beyond 5%, as we said, is pretty bad. So as you can see that there is no CNN because CNN has 100% predicted to be like 100% of the stocks were predicted to be below 5% MAPE, right? So above 5% is like Arima is performing worse here. So above 80% is Arima. So most here as we go towards the last phases, the SVR is performing worse. Similarly, there is a slant. So you can see that the SVR is higher than Arima, which is a bad sign, and then it is going like this. Similarly, for the global financial crisis, it is also you can see that the Arima and SVR are performing similar to each other. Now let's understand let's understand volatility analysis against the global events and algorithms. So the y-axis is represented by all the stocks starting from Apollo to India Hotels, and red is Arima, the cyan is CNN, and the purple is SVR. Inferences that we can get from this is the volatility. What we did is we performed volatility deviation. So if volatility is 0, which is predicted by the forecasting model, it is 0, then that means it is extremely accurate model. But we took a range of -5 to 5. It can go +5, it can go -5. So according to that, we can see that Arima is performing worse in terms of number of periods for each stock. CNN is consistently performing good, ranging between 25 to 35. We can also see that stocks of automobile, which is like Maruti, TCS, and Pharma, these stocks like have more volatility deviations compared to others. In terms of COVID, the fluctuation is even higher. In the global financial crisis, at least the CNN was working fine, but here we can see the fluctuation is extremely high. So the DV, the Bajaj, Hero, Maruti, which are all automobile industries, the DV is a pharmaceutical, the Thesis is IT, everyone is fluctuating too much. But as a whole, the CNN is performing far better than Arima and SVR. Now let's see the Russian-Ukrainian war. This is similar to the COVID-19 pandemic range. The stocks of automobiles, IT, construction have more volatility deviations compared to others. The conclusion is like CNN, we have seen from the analysis is that CNN has outperformed Arima and SVR in both terms of both MAPE score and volatility deviations. Arima performed better compared to Arima in most cases, except volatility deviation cases. We've also seen that automobile sector has shown high rates of volatility across all dimensions of global events. The pharmaceuticals and hospitals had high volatility, but with positive growth during COVID-19 pandemic. Mostly all sectors experienced moderate to high levels of volatility during COVID-19 pandemic. Public sector companies like ONGC, GAIL, IGL experienced moderate level of volatility. So we saw a volatility like 25 or 30, which is pretty high according to the standards. So and banking sector also experienced moderate levels of volatility during all the years. Now, each stock and sector tend to fall during the second phase. We have also seen from the forecasting charts that during the second phase, all the stocks were falling, but eventually, when it was the last stage, it suddenly moved up. That means the movement of the stocks we were able to predict. There's a pattern from second phase to the third phase, or second phase to the second last phase. The future recommendation is that stock data from other industries can be studied for a more comprehensive study. Learning algorithm efficacy can be improved using hyperparameter tuning. So in this particular model, we have tested the rolling window method of 7 days, but we can also test it for high or low frequency windows, such as 1 day, 2 day, 3 days, 10 days, all the way up to 1 month, 2 month, 3 months, and beyond. So testing window can be changed accordingly. Since CNN and ARIMA have performed better, deep learning models such as KNN, LSTM, and 7 models comprising ARIMA, CNN, ARIMA family of models, and hybrid TL models can be used to perform wide comparative analysis. So we, in the next future recommendation, we can say that we can incorporate many more models in order to evaluate many more industries across more global events. We can also consider exogenous variables such as news articles, tweets, YouTube videos, to further improve the model accuracy and crisis detection points. So this is the last slide. So thank you for your attention.